So chapter 8 is actually mostly all about circles, so we're going to start that here. This is what goes along with section 8.1 in your book. There's the pages, and we actually have 3 targets that you need to write down. So you need to know the different parts of a circle. So this is like the vocab you need to know. Then you need to know what pi is and how it relates to circles. What is that pi number? And then also using different formulas to find the circumference, the radius, and the diameter of a circle. So we're going to start with a story. I know we're in 7th grade and you don't get story time very often, so hopefully you appreciate this story. And I think it actually will help you remember the different vocab and how to tell them apart. So we're going to take some time to read it together. Your job after the end of the story is to summarize it in your own words and write down that summary in your notes. Here we go. Circumference and the first round table. So, long ago in a land known as Camelot, there lived many knights and ladies. Their ruler was a mighty but gracious king named King Arthur. During many years of peace and good harvest, the people lived happily. But the trouble began when their neighbors were gathering at the border. It looked as if they might be preparing to make war. So King Arthur called upon his bravest and most trusted knights to plan what to do. The knights rode as fast as they could to the king's castle. Circumference lived nearby, so his family came with him. Circumference was married to Lady Di, who came from the town of Ameter. And they had a son named Radius. Radius was very small and quite young, but his keen mind and boundless energy more than made up for what he lacked in height and age. After the first day of meetings with all the king's knights, Circumference sat with Lady Di. "Oh," he groaned, "my throat hurts. I have to shout to be heard at the other end of that long rectangular table. Everyone has to shout, and the king is very upset." "Why don't you fix the table?" suggested Lady Di. "How can we do that?" Circumference asked. "Well, she said you could cut it in half. Look, here's a drawing of the table. It has 2 long sides and 2 short sides. If you cut it in half and put those 2 halves side by side, you'll have a table with 4 equal sides." "Lady Di, what a good idea!" Circumference called for the carpenter, Geo of Metri. Geo began work immediately. The next day the table was ready. Everyone commented on the wonderful square shape. However, another problem arose. At each corner of the table, the knights whispered while somebody else was talking. Sir Galahad exclaimed, "King Arthur, how can we meet to discuss a solution when people talk secretly to each other?" "You are correct," King Arthur responded. "We've come here to talk about defending our land, not to talk in secrecy." So after the meeting, they worked again, and they decided, what if we cut it diagonally and put those 2 halves together to make a diamond? The king could sit at one end, you could sit at the other end, and everyone would be close enough to hear, but nobody would be any tight corners. So they made that table. Geo met with the carpenter, and he said, in the carpentry class, they call this shape a parallelogram. I'll have the table ready by the morrow. So they made the parallelogram table, but the others liked it, but King Arthur was not happy sitting at the sharp point. The king let them have jousting practice and said, "We need to figure out something else." So he met with Circumference again. So here's all the knights playing, practicing their jousting, and they all had triangular flags. "So that's it," said Circumference, "a triangular table." They were afraid one triangle might be too small. So they said, "Let's think some more," and Circumference went home again to discuss shapes with Lady Di. "Yes, the triangles would be too small, so let's cut off the corners like this and make an octagon." So when they sat at the octagon table, everybody wanted a side all to themselves. They had 8 sides and 12 knights. Who would share a side with another? They agreed that the king should have a side, but then that left 7 sides and 11 people. So they said, this won't work at all. Let's make a table the shape of an egg. Perhaps then we'll behave more like a flock. So here's their oval table. "This is going to be harder," said Geo, "because it doesn't have any straight edges. I'll begin at once." So they made the oval table. Sir Lancelot suggested they raise their goblets and drink a toast. All of the knights raised their goblets, but there was great commotion from the ends of the table. The knights at the ends of the oval table bumped into the king as they raised their goblets. No one had enough room. So this isn't going to work either. So Circumference goes home, and Radius piped up. "Father, when I have a problem I cannot solve, I do something else for a while. Why don't we go for a ride?" So that afternoon, Circumference, Radius, and Lady Di went riding. No one said much until Radius shouted, "Father, look! A tree has fallen over." "So it has," answered the knight. "Don't you see, Father? There's your table." Lady Di got off her horse for a closer look. She stood on her tiptoes and stretched her arm up as high as it could go. Her fingertips just met the upper edge of the trunk. "It should be big enough," she said. "This part is as tall as I can reach, and the wood seems to be of good quality." Circumference summoned Geo to cut a cross-section of the trunk to make into a tabletop. "Leave the bark on the outside edge," he told Geo. "I like its rough feel." Geo and his helpers sawed through the huge tree trunk, they hoisted it onto the ox cart, and off they went to the workshop so he could make the new table. When the knights met the next day, the table was finished. Everyone was content. No one shouted or whispered, no one felt cornered or trapped, no one was poked in the stomach, and no one felt squished. Everyone had an equal position around the table. As they talked, they decided the best plan was to try to make peace with their neighbors. So they announced they would celebrate that night. So they wrote their neighbors, and everyone was enjoying the dancing and music and banquet, and a messenger came and said, "The neighbors, they only want to measure the area of their kingdom. There actually will be peace." "Hooray!" said everyone. So the king held up his hands for silence, and he said, "To honor the knights who gathered at this table to save our kingdom, let them henceforth be known as the Knights of the Round Table. Let us thank Circumference and Lady Di and their son Radius. They made this round table possible. Furthermore, because Lady Di of Ameter has the reach that is equal to the distance across the table, we will name this measurement for her. We will call it the diameter." "I am proud of Radius too," added King Arthur. "Someday he will become a fine knight. He may be small, but he has tall ideas." Everyone nodded and clapped. "Let us call this small measurement from the center of the circle to its edge the radius." Finally, let us not forget our clever Circumference. Since it was his idea to leave the bark on the outside edge of our table, we will name the outside edge of any circle after him. Let us call it the circumference. So they all celebrated. The end. So summarize that story in your notes, and hopefully it helps you remember the different parts of the circle. We're going to go on and finish your sheet. Okay, so you're probably wondering, what is the official definition of the circle? A lot of times people say something that's curved, or something that's round-ish, or something where it's curved and all the points connect together again. Well, the actual definition, because I could draw things that are curved and still connect and get something that's not quite a circle. So the definition of a circle is actually all of the points, the collection of all of these points that are the same distance away from a center point. So if I pick a center and then measure out the same distance in every direction, all of these points are what make a circle. So it's all the points the same distance away from a center point. So let's keep going and write these down. Okay, Radius, you remember in the story, Radius was a little boy. He was as tall as halfway, the center, to the edge of the circle. So here's Radius. His height is the radius. That's the distance from the center to any point on the circle. Diameter. She was as tall as the whole circle, from the ground to the top. You can also draw a diameter that goes any direction. As long as it goes from edge to edge through the center, that's a diameter. And then circumference. He left the bark on the outside, so this measurement around the outside of a circle is the circumference. Think of it like the perimeter of a circle. So kind of draw those pictures or write those definitions down in your notes. Okay, the next thing, I want to talk a little bit more about circumference. First of all, if I have a diameter here that goes across the center of my circle, so that's a diameter, the length across the circle through the center, how many diameters do you think it would take to wrap around the outside of the circle? Starting at one point and wrapping all the way around till I get back to that point. So we're really asking, how many diameters would it take to equal the circumference? Well, if I take this distance, turns out I could lay it out here, like that would be one diameter. Then I could start again. If this was like a piece of string, I'm laying it out around the outside. That would be 2 diameters, 3 diameters, and I'd have this teeny little bit left over. So you might have a guess. How many diameters would it take to wrap around the outside of the circle? And I actually get this number. If I was really, really careful, no matter what circle I started with, it would take exactly that many diameters to wrap around. That's pi. So we spell it pi. It has this symbol. If I draw it, it kind of looks like that. Or here's the official one if you type it. Okay? It would take 3.14 of those diameters to wrap around. Pi actually keeps going. It has all these decimal places. It never ends. The button on your calculator will use all of those decimal places. But you just need to remember this. 3.14. That's why we got pi on Pi Day, March 3/14. March 14th is known as Pi Day. Okay? So, here's the lesson that you need to know. It takes 3.14 of the diameters to wrap around and make the circumference of the circle. Or, I could also say 2 times the radius, because 2 times the radius also gives me the diameter. Then times 3.14 would make the circumference. Okay? So, here's what you need to know. What is pi and how is it related to circles? Well, first you just need to know pi is 3.14 and it has this symbol. Secondly, you need to know that it takes 3.14 of the diameter to equal the circumference. Or the diameter times 3.14 will give you the distance around the circle. So let's fill this in on your notes. We haven't talked about area yet. You can ignore that for now, but let's look at the rest of it. Radius, distance from the center to the edge of the circle. If I know that and I wanted to find the diameter, if I wanted to follow this area and get the diameter, I would just double it or multiply it by 2. Same idea going backwards. If I know the distance all the way across my circle, I would cut it in half or divide it by 2, and that would tell me the radius. Okay? Or if I know the diameter, so if I'm starting with this distance, I can multiply that, this is what we just talked about it, multiply it by pi, or times 3.14, and that would give me this distance around the whole circle, the circumference. Or working backwards, if I started with circumference, divide it by 3.14, or divide it by pi, and that would give me the diameter. Whoops, that would give me the diameter. So, the idea here is if I start with radius, I can figure out the diameter and the circumference. Or if I start with circumference, I could figure out the diameter and the radius. So that's what we're going to do next. Here's your practice. I have a chart. I've given you either the radius or the diameter or the circumference. You have to find the other 2 things. So, like we just talked about, if I start with the radius, double it to get the diameter. If I then know the diameter, multiply it by pi to get the circumference. Or if I'm working backwards, divide by pi to get the diameter. And then take that and divide it by 2 to get the radius. Okay, so if you write that in, you should be able to find the rest of the blanks here. Again, don't worry about area, that's another video. So try each one, find the blanks in the chart, fill them in, pause, and then we'll come back and check. Okay, if you're ready to check, here we go. For these first 2, if I start with the radius, I multiply that by 2 to get the diameter, take that answer and multiply it by pi to get the circumference. So that's how we do those 2. Here, if I start with the radius, cut it in half to get the diameter, and then take your diameter and multiply it by pi to get the circumference. So times 3.14. So that's how we do those 2. And then your last row, or last 2, if I start with the circumference, I'm going to work backwards. Divide by pi to get the diameter, and then divide that by 2, or cut it in half to get the radius. Okay, so check that you got these answers. We'll do more practice together in class, but here's just a little bit, and just be sure that you can tell the radius, diameter, and circumference apart, like what part of the circles they are. And this section is just how do I start with one and find the other 2 if I need to.